Good afternoon, everybody. This is Melissa with Hidden Home Rabbitry, and today we are going to break down genetics. So exciting, yay! Okay, I know some of you out there are probably like, oh, this is stressful and anxiety-ridden, but I am here to try and make it less so for you, okay? So we're going to break it up today. We're going to talk about some of the basics of rabbit genetics and where things come from, where they go, where they come from, Cotton Eye Joe. I don't know. We're gonna figure that out today together. Okay. So let's just talk a little bit about inheritance. Okay. So rabbits in general, when we're talking about certain genes that they have two alleles. Okay. They get one from dad and one from mom. They never get two from dad and none from mom. They never get two from mom and none from dad. They get one from each parent. Okay, that's very important to know. So it's not as super confusing. One's going to come from dad, one's going to come from mom. And guess what? Like I said, each rabbit has, two genes they can give. So that means there's only two options that dad can give and only two options that mom can give. And the rabbit in question is going to get one from each. Okay, so you're not dealing with tons of different variables. You're dealing with just possibility of 4. Okay, so if you think about that, you can count to 4. You're good. We can do this. So take a deep breath, and we're going to break up into this session of learning about the basics of rabbit genetics. Okay, so rabbits have 5 different possible gene series, gene locus. So we have A, B, C, D, and E. Okay, A, B, C, D, and E. Now, under each section, there'll be certain genes in each series, but the color of your rabbit that you have at your house will be a combination of whatever these equal, okay? It'll have 2 A's, 2 B's, 2 C's, 2 D's, and 2 E's, okay? That's it. And that makes up the color of your rabbit. So it's not that hard. We're just going to have to start from the basics and go from there. Okay. So, rabbits inherit one gene from each parent, and depending on what the parents have is what they can give. So, let's talk about, I would normally start with the easiest one to understand, which would be the B series right here. But you know what? I just want to go in order, and we're going to talk about the A series, okay? A series. We can do this. We can start this. Okay. So, before we get started with the A series, I want to talk about the simplicity of a Punnett square. Okay, a Punnett square is, a giant square like this. Doesn't have to be giant. You can make them as small as you want to. But we are going to have dad up here, dad's genes. And then over here, we're going to have mom's genes. Okay. And like I said, they got 2. So dad's going to go here, mom's going to go here, and we're going to plug and play. All right. So just for simplicity's sake here, we're just going to choose some random letters, not these. So we're not going to deal with these. We'll say that dad is giant X and little x. Okay. And mom is giant X and little x. Okay. Do you kind of see that? So when you are looking at a Punnett square, the genes on this side will go that way, okay? And the genes on this side will go that way. So when they meet together, you pair them together, okay? For this example, the capital letters will go first. And many of the rabbit genes, capital letters are dominant genes, and dominant is always what's going to show up, okay? So we have a big X, that's indicative of a dominant gene, and there's his second gene, which is a little x, which is indicative of a recessive gene, okay? So we have a dominant gene here on mom's side and a recessive gene here on mom's side, okay? So when these two play, we have the dominant gene and the dominant gene, we're going to have 2 big old dominant genes there, okay? And then this comes down here. That one goes over here. Now, remember I said we have so in this box, we're going to have a big X and a little x. And remember, dominant goes first, okay? You're going to have a big X and a little x, like that. Do you understand that? You see how that happened? So we have the dominant gene and then the recessive gene. Now, going into this box down here, we have dad's dominant gene going down, and then mom's recessive gene going this way. Dominant goes first, so dominant is what's going to show right there. And then look, we have dad's recessive gene over here and mom's recessive gene over here. So guess what? We're going to have a baby that has two recessive genes. And so this is the gene that shows on the rabbit. This is the gene they hide or carry. And so as their second gene. Now this gene can influence how this one expresses and shows itself. Not always though. Most of the time actually it doesn't. This is the gene that we will see. Okay, that's visually. So we are seeing this first gene here. So that means if we're looking at four babies from these genes of these parents, 3 of these genes of the babies here, these potential babies will all look the same. And then this one will look different. Now, statistically, you can look at this and say 3/4 of this potential crossing will look this way and 1/4 won't. Okay, so if you're dealing with an average size of 8 kits in a litter, that means 6 of the kits will look one way and then 2 of the kits will look a different way, statistically. Okay, keep in mind that's not reality. Sometimes that's statistics. Okay, so that is how the Punnett square works. Let's do another one. All right, let's make up another one. Let's take one of those babies. Okay, let's say we're going to take the baby that was capital X and capital X. He was a boy. He's now the new dad. Okay, and then so he's now the new dad, and we're going to pair him to the mom. Now she has 2 little X's. Okay, so we're going to say mom over here. All right, so if the dad has 2 dominant genes, or at least, the first one is what's going to be showing here, but he carries that dominant gene as well. He does not carry a recessive gene, but mom is a recessive gene shower and carrier. Okay. Then all the babies, as we are, again, remember they go that way and these go that way. So as we come down here, the dominant gene goes first, the capital letter goes first, and then the other one comes over. So we have this one and this one. Big X and little x, you're going to have big X and little x. With big X here and little x here, you're going to have big X and little x. Now, what do you think we're going to have here? You have a guess? If you said big X and little x, you were correct. Good job. You're smart. You're learning. Look at that. All right, and look, last one. Big X and little x. How fun is that? So the entire litter is going to be genetically the same. Okay, because dad could only pass one of his 2 genes and mom could only pass one of her 2 genes. So the entire litter is going to be this way. Okay, you're going to have all the babies are going to be looking like dad. They're going to look just like dad, but they're going to carry mom's recessive gene. Okay, so that is, how the basics of how kind of Punnett squares work. You have 2 genes, kind of make a big old square, and then you just kind of plug and play. Now, let's talk about this. Why don't we do this? Let's show you real quick. Why don't we do this? Let's say, again, we have, dad is big X and mom is little x and little x. So why don't we do this? Little x and big X, little x and big X. Okay, why isn't that an option? Well, that just has to deal with how the genes show themselves and display themselves. So in this case, you can't have a recessive gene hide a much more dominant one, because that dominant one wants to be in your face and proud of it. Okay, it is going to be what's showing. This little recessive one, it just can't hold its own. Okay, it can't push that bigger gene back and be the one that shows, and then this other more dominant gene is the carried one. Unfortunately, or actually fortunately, because it kind of makes sense, it follows the rules, and recessive cannot carry dominant. It's very important to remember that. Okay, and so we never write it like this. You never put little before big. Okay, you never put the recessive in front of a dominant gene. So it'll always be dominant first and then recessive. You'll never have it the other way around. It will never, ever, 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 ever be that way. Okay. And anyone who says otherwise does not know what they're talking about. So this is just the simplicity basics here. Now let's go back to, like I said, we're talking about today the A series. Woohoo. So much fun, because I'm going to throw in a little bit of a wrench here. When we're talking about the A series in rabbits, it's like, I would consider them a foundational series. In A, we have 3 options, not 2. Now don't get overwhelmed here. Don't get overwhelmed. Take a deep breath. Take a deep breath. I know I said 3 options. And how can there be 3 options when rabbits only have 2 genes? It's okay. It's okay. Breathe. Breathe. Breathe with me. We can do this. All right. In the A series, we have 3 options. We have the dominant, which is the big capital A, and it stands for agouti. Okay? Agouti. Agouti is dominant. Agouti is always dominant. It is the most dominant of the 3. Now, we're going to be a little bit fancy here. We can do this. I believe in you. Our next one is actually 2 letters, but we can do this. A-T. You're like, what? I didn't name these, okay? I just remembered them. I just memorized them. You just got to memorize them. You can do this. A-T. That is for the otter gene, okay? There's the otter gene. And then, lastly, we have the most recessive of all, which is the self gene. Okay, you're like, what? This doesn't make any sense. Don't worry, we're going to get through it. Okay, so agouti is the most dominant, and then coming in the middle is otter. And then coming in most recessive is self. Okay, so how does this work out in real life? All right, so let's talk about some agouti colors. We have colors like chestnut. Okay, we have colors like opal. We have colors like amber or chocolate agouti, as it's called in some breeds. We got lynx is another one. Okay, those are all agouti colors. All right, and then otter. Likewise, we have black otter. Okay, we have blue otter, chocolate otter, and we have lilac otter, right? And then the self is not too much different than the otter, because all you got to just do off is take the otter off, and then suddenly you just have black, okay? Black and blue and chocolate and lilac, okay? These are just some basic examples. Now, they do get a little bit more complicated when you do other colors, other gene series. The C series can change things. The E series can change things. We're not worrying about that right now. Right now, we're just doing A, A-T, and A. Okay, you got it? Following me a little bit so far? Okay. If you're confused, it's okay. We're going to get through it. All right. So these are just some examples. So let's go ahead and make a hypothetical rabbit up. Now remember, a rabbit has 2 genes. Okay, and remember what I said, dominant goes first. Going back to this page here, agouti is the most dominant. Okay, it is dominant to otter and self. Okay, otter, it is recessive to agouti, so it will hide under agouti, but it is dominant to self. Okay, so if you have a rabbit that has these genes or whatever involved, otter will show up and it'll hide the self, could hide the self. And then if you have a self rabbit, it cannot be hiding either of these genes. Okay, so when we're talking about recessives, here's another important thing to know here. We're talking about recessives. An animal who is the most recessive, let's say they're a self rabbit, will always have 2 copies of the same gene, AA. Okay, because remember what I said, it cannot hide a more dominant gene behind it. That's just not how it works. So and because rabbits have 2 genes, they're going to get 1 from each parent mandatorily. You're going to have 2. The only option, if you have a visibly self rabbit, they have to have 2 copies of A. Okay, and this doesn't have to just pertain to self. We're just talking right now in the A series. So if you have a self rabbit, it's going to have 2 copies of the self gene. Okay, you will not be hiding any of the other genes. That's just how recessive genes work. Okay, so let's do some hypotheticals here. All right, let's say you have a chestnut buck and you want to breed him to your black doe. Okay, so you have to know a little bit about chestnut and black. You're like, what are they? Well, agoutis are very stereotypically will have rings in their fur. Not always, there are some exceptions to this, but generally will have rings in their fur. They have very complex colors in their fur. If you split their fur apart, you're going to see bands of color in the fur, and that's very typical of agouti rabbits. The otter will look a lot like the self rabbits, okay? Like a black rabbit will look a lot like a black otter. They will be very, very close, except otter will have otter markings on it. And otter markings are tan patches on the bellies, behind the ears, on the inside the ears, around the eyes, on the nose. So you'll see that. I will try show on later in this video when I actually go out and show you some real life examples of these series of colors. And I'll try and show you the differences and what sets them apart. But for the meantime, we're doing the book work right now. Okay. All right. So let's do what I said. We had a chestnut buck and a black doe. Okay. So we're going to make our little Punnett square here. Like I said, you can make these as big or as little as possible or as you want. I'm just going to make this a little bit smaller so I can fit more on the page. How about that? Because we're going to do a bunch of different tests. And no, my square is not perfect, but whatever. It is what it is. You know, I'm human too. All right. So in this situation, I have, remember, my buck, my dad, he's going to be up here and he's chestnut. Okay. And then my mom, the doe that I'm working with, she is black. Now remember what I said about black. Okay. It can only carry a copy of itself. Okay. So she's only going to have 2 recessive little A's to work with. Now I'm just going to make this hypothetical buck. I'm going to pretend like I know what this is. And I'm just going to say he is a agouti. He's a chestnut and he carries chestnut. Okay. So remember what I said? The dominant goes first. All of the babies are going to be this. Capital A, little a. Capital A, little a. Capital A, little a. Capital A, little a. Okay, do you see how that happened? Remember, we kind of, when the letters are up here, we go downwards. When the letters are over here, they go that way. And when they meet, that's how you fill it in. Remember, little ones don't go before big ones. More recessive ones cannot hide more dominant ones. So you're always going to have the dominant show up here. In this scenario, we have all of the babies are visually this, okay? And remember what I said? So all of these babies are visually going to be chestnut, okay? They're going to look just like dad. So you're going to have a chestnut buck and a black doe here. And it's all going to be chestnut babies, okay? However, they carry one of mom's little A genes here, okay? Now let's say you take 2 of those babies. I know. Like, oh no, you're going to breed them together. Okay, these are fake babies. Also, you know, line breeding's a thing, whatever. So we're going to take a brother-sister here. Or if you'd like to think about it, let's take a boy and then the girl from another litter, okay? Whatever floats your boat. And we are going to cross these 2 now, okay? Now remember, these go down, these go this way. When these 2 meet, what do you think we get? Any guesses? If you guessed capital A, you were correct. Good job. You have one baby who is going to be chestnut and only carrying that agouti gene as well, okay? We're going to have one of those, agouti carrying agouti, all right? And this one, what do you think we're going to get? If you said big A carrying little a, you were also correct. Go ahead and give yourself a round of applause. You're going to have an agouti animal carrying self, okay? Again, what do we have going on here? We have big A over here, little a over here. Any guesses? Again, we're going to have one of these, all right? agouti carrying self. In our situation, it's going to be a chestnut rabbit who carries the gene for self. Going to have black ones. Now, what do we have over here? Any takers? Any guesses? If you said little a, okay, you're smart. Okay, see, look at that. You're doing Punnett squares. You're doing genetics. You got this. Look how smart you are. Okay, we have a visibly black rabbit, and or in this case, at least a self-colored rabbit. All right, we have a rabbit. So 3/4 of the litter are going to look like this. Remember, this is called the phenotype. You can say that word, phenotype. This is what it's going to look like. But the genotype are both the letters together. That is part of the genotype. But the phenotype is the first letter. All right. So phenotypically, we have 3 big A's. Okay. So we're going to have 3 agouti based, or at least in our scenario here, 3 chestnut. And then we'll have 1 for a self-based rabbit, which would be in our scenario, a black rabbit. All right, so we're going to have 3/4 of the litter look chestnut, 1/4 of the litter look black. You following me? Okay, this is just kind of like how we were doing earlier with our X's, right? All right, so what about this otter gene? How does that fit into things? Don't worry, let's do this. All right, so we're going to make another box over here. Now, let's say you take, we're going to do another chestnut, okay? But this time, he carries otter. Goodness, he carries otter instead, all right? There's no self, there's no 2 genes of agouti here. There's an otter gene. And now, let's say you take them and you cross them to your first doe again. You're like, oh no, we got all 3 genes up there. What do we do? It's okay. It's okay, breathe. We got this. All right. All you got to do is plug and play. What do we got going on here? We have this gene coming down, that gene going over there. What do we got? If you said this, you were correct. We have an agouti gene and then coming into self. All right. Now, just to refresh our memories here, this is the order of operations, okay? We have this order of dominance going on. So this is the most dominant. This is the kind of mid-range dominant. And then this is the most recessive. Back to our Punnett square here. What do we got going on here? So what is Dad now passing? He's passing his otter gene over here, not agouti anymore. He's passing his otter gene. Is otter dominant or recessive to self? If you said dominant, you were correct. So in that case, we have the AT gene first and then the little a afterwards. All right. So we have otter carrying self. In this situation, what do we got going on? We also have, just like the one up here, agouti carrying self. And again, just like we had up here, we're going to have otter carrying self. Did you kind of follow that? So that means, although we have our black doe here, we have our chestnut buck here, we have this chestnut buck carries this otter gene, okay? So when he passed his genetics, remember what I said, they pass him out 50% of the time to each kit, all right? There's just statistically, that's kind of how it works. So 50% of the litter will be agouti carrying self, because if you look at our box here, you can see what our outcomes are going to be. And we have 2 big A, little A boxes. That means 50% of our litter will be agouti carrying self. And then 50% of our litter will be otter carrying self. Do you see that? We have ATA and ATA, all right? That's just statistics. Otter is recessive to agouti, but dominant to self. All right, let's do another one. Let's say we have, one of these going on. We have a chestnut once again. All right, visibly a chestnut here. This time, what do they carry? What are they hiding? They're carrying a self gene. All right, and we're going to cross it to a black otter So we're going to make it AT over here. And then we're also going to give it an A gene to carry. Maybe we took one of these babies and decided to grow her out and breed her. Okay. So what do we got going on now? Well, like I said, let's plug and play. So we have our agouti father here passing his big A gene, and then the black otter mom passing her gene, okay, her otter gene. So what are we going to have? What's going to go in this block? Any guesses? If you said AAT, you are correct. Good job. Give yourself a round of applause. All right. You have a visibly agouti rabbit or chestnut rabbit in our scenario here carrying that otter gene. Now, what do we got going on over here? We have dad's little A gene and mom's black otter gene. What's going in this box? Any guesses? Well, if you said ATA, you are correct. Remember, otter is dominant to self, okay? Otter is dominant to self. It won't ever be AAT. Well, I mean, okay, AAT as in big AAT, but like little AAT. That's not a thing. Recessive cannot hide something that's more dominant. So you're going to have otter carrying self. Let's do this one. What do we got going on over here? So we have a big A and a little I. What are we going to get? You said this. You are correct. Good job. All right. And then for our last box, any guesses? All right. Yes, we are going to have two little A's. So look at our crazy litter now. It has all these random genes in here. What are they going to look like? Well, like I said, remember that first gene right here, that is what's going to show up on the animal. All right. In this case, we have agouti and agouti. So half of the litter will look agouti, will look chestnut, but they will carry different genes. Do we know which of the chestnuts will carry otter or which of the chestnuts will carry self? We don't. We don't know. It's going to be a 50-50 chance of which one they carry. But, they're going to carry one of them. And in this situation, now we have one box that is AT little a, and we have another box that is little a little a. So if 50% of our litter is going to look chestnut, that means 25% is going to look otter and 25% is going to look self. Now, these are the only combinations that you're going to be able to get, so you know that any otter coming from this pairing, this specific genetic pairing, is going to carry that self gene, okay? And then, of course, all your selves, they're most recessive. It's just going to be double of the same letter. So we have a 50% and then a 25% and a 25%. Y'all following this so far? See, when you're dealing with 3 genes, it's not that bad. Let's do another hypothetical situation. Let's see. Any guesses here what we're going to do? Let's say you're going to cross 2 otters. We're going to have an otter who is AT, all right? And now we're going to have a rabbit who's also an otter, but they're going to be ATA. All right, so what are we going to get? So we have dad here. He's an otter and he carries that second otter gene. Now we have mom who's an otter, but she carries that self gene. All right, let's go ahead and fill this out. AT, and then AT, whoops, AT. And now we have ATA and ATA. All right. All of the litter will look otter. All right. We're going to have half of the litter be AT like dad, and half of the litter is going to be ATA like mom. Do you know which half? No, probably not, because self will hide under the more dominant gene of otter. So you don't know which one. They're all going to look the same. Okay, they're all going to look like black otters or whatever color we're working with. But in this case, they're all going to look otter. And the self ones are going to not look any different because they're hiding that gene. So in order to figure out which one is which, you're going to have to test breed. And you're like, what is test breeding? Well, let's say you take one of these babies, all right? You take one at random. Let's say you grab this one. Should have put my box in here first, but I didn't. I'm going to leave that one blank. And you're like, oh, no. Oh, what? How are we going to answer this? How are we going to fill this out? Okay, breathe. We'll figure it out. I'll show you in just a second. Now, this is where you look at the kits to determine the parents' genetics. Okay? So in all these other situations, we knew the parents' genetics going in, so we knew what we were going to expect. Most of the time in rabbit breeding, the only gene you know in a rabbit is that first gene. Okay? You're only going to know that first gene. You don't know what the second gene is unless you know all the genetics, because you're only going to go off based on what you see. Okay? So let's say you take one of these black otter babies from this one and you're going to cross it to a self. Okay? You're going to cross it to a self rabbit. Now with self, we do know, okay? We do know the genes are both little a, because like I said, self can't hide anything that's more dominant. So it's going to have just 2 copies of itself. So what you're going to expect, at least in half the litter, all right? Because we don't know what this one is yet. You're going to expect to see this. You can say they're going to be half otter, all right? Okay, so let's say you breed this buck and you breed it to this doe and she kindles and the babies are born, and you look at the babies and you realize you see some self babies in there. Okay? You see some self babies. You see some self-colored babies. All right? So you're dealing with otter and self. So does that answer what this could be for you? Well, if it was AT, all right? If it was AT, now we can plug in this back in the equation here. If it was AT, then you would not see any self, right? Because all of them are going to be visually this, carrying this. All right? You following me so far? So let's say, like I said, you see some self babies in there. All right? So you know it's not that. It's got to be this. That was our only other option, right? We didn't know if it was going to be one of these or one of these. So knowing that we have some self babies in there, we no longer have these. We're going to have AA. So now we have little a, and little a, little a. Do you kind of see where we went with that there? We used what we saw in the outcome of the kits to determine what the parents' genetics are. And that's something you often do in rabbit breeding, because you don't know what you don't know. So a lot of people, when they write the genes of their rabbits out, you're going to have people write something like this. Okay? We're going to have what we see, but we don't know what we don't know. Okay? We don't know what that second gene is. Again, this is what we see. We don't know what we don't know. This is what we see, and we don't know what we don't know. It goes all the way down the line. Do you kind of get where I'm going with here? So sometimes you can't fill in that blank, right? Not yet. But you can look at the babies to answer the parents' genetics. So when you're dealing with the A series, you're only ever going to have those 3 genes. A, AT, and A. That's it. Now, some of these other ones can get a little bit confusing, but when we're dealing with just the A series, we're only going to be dealing with these 3 genes. Y'all tracking so far? Got it? All right. So that's what we're going to be the conclusion of our video today. I didn't want to make it too long. I'm going to go out and show you some actual examples now of some rabbits that are going to be agouti colored, that are going to be otter colored, and they're going to be self colored. Now, I don't exactly have chestnuts and black otters to work with, but I do have those genes to work with. All right, so don't get confused. Don't get lost in the sauce. All right, you'd be like, oh, why is it blue? Why is it this? Why is that? Don't breathe. Breathe with me. Breathe with me. We got this. I'm just going to show you some real life examples. Okay. All right. Here is one of my agouti rabbits. Now these are Rex rabbits, and the fur is a little bit different here, but all genes are the same regardless of the breed type. Sometimes they express a little bit differently, but they're all pretty much the same. So this is my agouti rabbit. She is a chestnut, or as they call it in Rex, they call it the color castor. No, I did not make up these names, okay? I did not. I don't know why they don't just call it chestnut, but whatever. We're just going to go with it. It's castor, but genetically, we have a capital A rabbit here. All right. Remember how I said that agoutis have very colorful, complex colors? Look at the bands of color in her fur. Do you kind of see that going on there? We have like a beautiful dark slate gray undercoat. We have a orangey midband, and then the very tipping of her fur is almost like black colored. She's a gorgeous rabbit, aren't you, girl? You're so pretty. Yes, you are. And so they are very colorful rabbits. You can see the ears are a little bit lighter, very complex colors. Where are you going, sweetheart? The eyes, they have some rings around the eyes, the chin area here. Now I'm going to show you her belly if I can. All right. Do you see how her belly is light colored? It has a little bit of tan along the side as it fades into her color. She's got a white chin area. All right. So they have very complex, beautiful colors. All right. And here we have an otter example. Otter is recessive to agouti, but dominant to self. This here is a blue otter. I know we've been talking about black otter. Don't have one, but I have a blue otter. All right. So when I was talking about how they look very, very similar to their self counterparts, she's very just gray looking. But if you look, here we have otter marks. The ears have an orange tan knit to them. Behind the ears, you're going to have some orange tan patching. There are rings around the eyes as well. The nose is a big tail as well. Come here, let me see your nose. Give me, sweetheart. Whoops. Do you see how there's like orange on the nostrils on both sides? Indicative of an otter. Now let's check out the belly. And here we have the belly of this little guy right here. Again, light colored belly. We have a little bit of orange band right there where the colors meet. There's the little orange little patch in his little nostrils. So cute. But otters will have light colored bellies. All right, and here is our self example. It happens to be a blue self. I don't have a black self, but you can compare it easier to the blue otter that way. Looks very similar to the blue otter, except no, look, no tan rings around the ears. There's no tan patch behind the ears. No tan ring around the eyes. No tan bits to the nose. All right. Oh, and one thing I did forget to show you is the fur. The otter will be the exact same as the self here. Do you see any rings in the fur? No rings in the fur. The otter has the exact same way. You're not going to see rings either. Only agoutis will have rings. All right, now let's look at her belly. What do you notice about this one? She has a blue colored belly as well. Selfs will not have white bellies. They have the same color as the color on the back of their body. All right, and you see there's no orange nostrils here or anything. So this here is a self rabbit. All right, so I hope you all learned something today about the A series in rabbits. Again, agouti, then otter, then self. It's not much more complicated than that. All you have to do is plug and play in the genes. Now remember, each rabbit will only have 2 genes to pass. Sometimes you need to figure out which those 2 genes are, but it's not that complicated, all right? Anyways, I hope you all have a great day and you learned something. Stay tuned for my next video coming out soon.